Alright, so in this video I'm going to be showing you how to take absorbance values that you've measured, match those up with concentration values for each of the solutions that you measured, and turn those into a scatter plot in Excel. So the first thing you're going to want to do is take the absorbance values that you've measured, place them into a column such as I've done here. Make sure to label them absorbance so that you know that these are your absorbance values, and then enter the various concentrations of the solutions that correspond with those absorbance values as I've done here. Now after you've done that, you're going to want to go up to the top and select Insert. Just left click on that. Go over to the Charts section and select the drop-down menu for the different scatter charts. Just left click that. Then go right here and select just a standard scatter plot. Now Excel might automatically put in some data, but do not take that for granted and do not assume that it is selecting the proper data to go on your x-axis and the proper data to go on your y-axis. It's important that if it is already pre-selected for you, you double check and make sure what's supposed to be on your x-axis is your x data and what's supposed to be on your y-axis is the proper data for your y. So we're going to left click here, going to left click on the chart. We're going to go down to select data, and click that. And we're going to click edit for whatever data it's already selected. Now mine has selected just some empty cells here, but yours might select something different. It's important to put in a good name for your data, so we're going to call this standard curve with Bradford reagent. Then we're going to select our x values. So our x-axis should be the concentrations of the solutions that we were using. So to select these, we're simply going to go over to where our concentrations are listed. We're going to left click and then drag all the way down until we've highlighted all of our data, and that will select our x values. For our y values, we're going to do the same thing, only for our absorbance data. So we're going to go over, left click, drag all the way down until all those are highlighted, and that will be all of our y values added in. Then we're just going to hit OK, and we're going to hit OK again, and there we have it. Our data's been added. Now we're going to want to add a trend line to this graph to see how good of a fit this data is to just a straight linear line. So to do that, we're going to left click one of the data points, and then right click and go down to Add Trend Line. Once we've done that, it's important that you make sure linear is selected. It should be selected automatically, but just make sure that that's selected. Go down to the bottom here and select Display Equation on Chart and display our squared value. Now once we've done that, we should have an equation for this trend line pop up, and we also should have an R-square value pop up. Now basically what an R-square valued is a goodness of fit. It's how well does this linear line fit to the data that we have put into the graph here. And an R-square valued of greater than 0.99 is considered to be a very good fit, whereas anything less than 0.99, really down to 0.98 or 0.97 is a okay, not super great fit, and then anything less than 0.97 is really not much of a good fit at all. All right? So now that we have that set up, we can see that our data is an okay fit to this line, but in all truth, it seems as though a few points are skewing it off a bit. And one might ask themselves, why is it that our data is a little bit off? What is throwing it off? Well, if we look at the overall shape of our data set, we can see that there's a very clear linear range, right? From here probably up to this data point here, it's pretty much just a solid straight line. And then after that, we begin to develop a non-linear range where it begins to curve almost, as you can see here. Now, that being said, if we were to remove those last two data points, we'd be able to get a better fit to just this straight linear line. So let's go ahead and let's do that. We're going to just copy our values for our absorbance data over, and copy our values for our concentration over, except for the last two data points, of course. So just select all of them, go on down except for the last 2 points, and just copy and paste it in. Same thing, Control C, Control V. There we have it, and we have a new data set, and we're going to go through the same process and insert a new graph, only this time without those last two data points that were throwing us off. So same process, go up to the top of the page, select Insert, go over to Charts, select Scatter, just a plain scatter. We're going to once again need to make sure that the data it's selected for our x values is in fact the data we want to be our x values. So select Data, hit Edit. We're going to call this, so let's see, Standard Curve with Bradford Reagent. And I'm going to call this one Edited so that I know that it is just the same curve, only minus the last two data points. Alright, so our x values, we're going to select all of our concentrations. Our y values, again, we're going to select all of our absorbance data. Let's do that real fast. There we go. And we're going to hit OK. And just hit OK one more time. And then we're going to left click on one of our data points, right click, select Add Trend Line. We're going to go down to the bottom where it says Display Equation on Chart and display R squared. And there we have it. We have a new chart made that is a better fit to our trend line. And you can see that listed here with a higher R-square valued of 0.995. So this is quite a good fit. Now, one thing you might be wondering is, why is it that those last two data points existed? Why is it that we began to plateau out toward the top? We had that nonlinear range develop. Well, at this point, it would be a good idea to go back and take a look over your lab manual with a special emphasis on the area concerning how the Bradford assay works and exactly how the Coomassie blue is measured. So really take a look at that, really consider how it is you're measuring these absorbance values, and begin to consider what would happen at those higher concentrations of protein. What begins to happen as you add more and more protein and the Coomassie blue stays the same. So with that being said, I hope that this video has helped you, and I hope that you have good luck on your lab and everything goes well.